Everyone's talking about modular blockchains. Celestia, EigenLayer, Avail. Big names with big promises. But what do they really change for users, developers, and liquidity? And how do they connect to the Layer 2 story we already know? Let's start with the basics. A monolithic blockchain tries to do everything in one place: execute transactions, order them, prove them, and store the data forever. It's simple to reason about, but hard to scale. As usage grows, one system struggles to serve 4 jobs at once: execution, consensus, data availability, and settlement. Modular design breaks those jobs apart. One layer focuses on execution speed. Another layer ensures ordering and consensus. A third guarantees that data is published so anyone can verify the chain. Settlement, the final court of truth, can live on a secure base like Ethereum. Specialization creates predictable scaling. If execution is the bottleneck, add more execution lanes. If data is the bottleneck, expand capacity without redesigning the rest. So what do Celestia and Avail promise? They offer scalable, verifiable data availability for rollups. In a rollup, data availability means every transaction's data is posted somewhere public, so observers can rebuild the state and check for fraud. Traditionally, rollups post that data directly to Ethereum. It's extremely secure, but expensive and bandwidth limited. Celestia and Avail say, let us handle the data. They use data availability sampling so light clients can verify that the block data really exists without downloading it all. The result is cheaper, more abundant space for rollups to publish data, while settlement can still happen elsewhere. In practice, this means dozens of execution layers, even app-specific rollups, can publish their data to Celestia or Avail and still settle to Ethereum or another hub. That's the modular idea. Pick the best tool for each job. If throughput spikes, scale execution. If data costs rise, scale the DA layer. The system becomes a set of modular components instead of one rigid chain. Now bring EigenLayer into the picture. EigenLayer introduces restaking on Ethereum. In simple terms, ETH that's already staked to secure Ethereum can also opt in to secure new services called actively validated services, or AVSS. These can be shared sequencers for rollups, Oracle networks, or committees that verify data availability. Restaking reuses Ethereum's economic security to bootstrap new infrastructure faster than starting from zero. Why does that matter? Because bootstrapping security is the hardest part for any new network. Without enough stake at risk, attacks are cheap. EigenLayer turns Ethereum's staked ETH into shared security collateral. Stakers opt in, accept extra slashing rules, and help secure an AVS. If the service misbehaves, their restaked funds can be penalized. That makes attacks expensive and accelerates the path from experiment to production. But restaking isn't free magic. It adds new risks and governance challenges. If an AVS has unclear rules or bad code, honest stakers could get slashed unfairly. And if too many systems depend on the same restaked ETH, a single failure could ripple across many services. The upside is faster bootstrapping and shared security. The downside is complexity and new coordination risk. So how do all these pieces connect to Layer 2 networks? Rollups gave us cheaper execution and Ethereum-level security. Modular DA layers promise cheaper data posting so rollups can scale further. Shared services powered by restaking, like decentralized sequencers, aim to reduce fragmentation and create fairer ordering. Together they form a modular stack. Execution spreads across many rollups. Data and sequencing consolidate into shared utilities, and settlement anchors on a credible base. For users, the goal is simple: lower fees and smoother experience. If DA costs drop and sequencers are shared, bridging becomes easier, and finality feels faster. Ideally, users don't care which chain runs the transaction. They just tap swap, and it works. For developers, The goal is faster deployment and clearer trade-offs. You can launch an app-specific rollup with your own fee policy, inherit strong data guarantees, and settle disputes to Ethereum. For capital allocators, the goal is sustainable security and real revenue. DA fees, sequencing income, and restaking yields should come from real usage, not temporary incentives. Now let's stress test the promises. First, data availability. Cheaper DA is great, but trust assumptions change. If you post to Celestia or Avail instead of Ethereum, you rely on their validator sets and economics. If they fail, can your rollup recover? Do you have data backups or escape hatches? Good systems plan for the worst day, not the best day. Second, shared sequencers. Centralized sequencers are fast and simple, but create single points of failure and possible MEV abuse. Shared sequencers promise neutral ordering and less censorship risk, but they must still be fast, fair, and reliable. If multiple rollups share one sequencer, that layer becomes critical infrastructure. Who governs it? What happens during outages? Third, restaking. Reusing ETH security is efficient, but stacking slashing conditions amplifies risk. If an AVS breaks rules, could large amounts of ETH be penalized? Would that stress Ethereum's base layer? The answer depends on how isolated each service's risk really is. Even with these challenges, the trend is clear. Execution fragments across many rollups while security, data, and ordering consolidate into shared layers. Instead of one chain doing everything, we'll have many chains for execution and a few neutral hubs for verification. That's how you scale without losing credible neutrality. Will Modular win automatically? Not necessarily. More moving parts mean more edges where things can fail. Coordination, incentives, and governance must align. If a stack becomes too political or too fragmented, builders will choose a simpler, even if less elegant option. The real winners will be stacks users never think about because everything just works. Fees feel low. Finality feels quick. Apps feel native. On-ramps from fiat are seamless. Here's a short weekly checklist to evaluate modular stacks without the hype. 1. Data cost versus throughput. Are rollups posting more data for less money, and does the DA layer stay stable under pressure? 2. Settlement credibility. When disputes happen, is there a clear path to finality on a credible base like Ethereum? 3. Sequencer neutrality and uptime. Is ordering fair and resistant to censorship, and how are outages handled? 4. Restaking risk controls. Are slashing rules clear, isolated, and enforced transparently? 5. Real adoption. Are developers staying, users converting from fiat easily, and revenues stable when incentives pause? If 3 to 5 of these stay green for the same stack across months, it's probably more than a narrative. It's becoming default infrastructure. Celestia and Avail promise abundant, verifiable data space so rollups can scale. EigenLayer offers a market for shared security so new services can launch quickly. Anchored by Ethereum settlement, these layers outline a path where we scale by specializing, not by stretching one chain past its limits. Ignore slogans, follow guarantees, follow distribution, and always ask the question that cuts through hype. On the worst day, when something breaks, which stack still settles the truth? This is not financial advice. It's a simple framework to judge the modular promise and track where trust and liquidity will settle next.